So we're going to step into our workshop and, obviously we're all here. You're out at the bar. All of a sudden the boss texts, how much is this going to cost? And you're like, oh, damn. Okay. So what bill are we talking about? So we're going to have a little fun. We've got HR 1776, free ice cream for all Americans on July 4th. Because what goes better than with hot dogs and hamburgers than some ice cream to go with it? So obviously, based on this, what are we missing? We need to consider some of the, what do we need to understand? What data do we need to consider? And Dr. Beach, afterwards, as we're eating our lunch, is going to step into how would you frame this request to the CBO. So, all right, let's think about this for a second. And before we jump into it, and we've got a good example for us to work through, what details are missing from the question? Well, first and foremost, I can't score anything if you don't have some legislative language or an understanding of what to look at. So we need to look at the legislative language. That legislative language should guide your information and how you frame the question. So let's think about this for a second. Just off of the basics, free ice cream for all Americans. Well, we probably have to identify how many Americans are going to go take this up. Well, also we have to consider what is the cost of ice cream. Then we have to consider how many people are actually going to go out and take advantage of this free ice cream. What is that adoption rate of it? I love ice cream, so I'm probably going out and getting some. Maybe some people don't, they're obviously wrong, but not everyone's going to go and maybe take advantage of the free ice cream or anything else. From there, again, what Parker highlighted earlier, growth rates. How are we looking at the growth of both the US population and the inflation? And how long is this provision going to go? Are we saying that just for our 250 anniversary, everybody's getting it? Or are we saying that this provision is going to be every year for 10 years? These are options and things that we need to consider. So, a couple of questions that we can frame to the CBO is, what inflation rate are we using? Well, this is a little different. If anyone's aware, grocery prices have grown a little faster than the regular CPI rate. We also want to be mindful that we're not using core CPI that Parker used earlier, because core CPI removes food and fuel. Well, pretty sure ice cream's a food. Maybe not one of the primary food groups, but still important. And then from there, how are we focusing on the growth rate of the population, and how are we assuming the adoption rate that the people are taking this up? So I'm going to have you jump into this workbook in just a second on the next slide. I want us all to go back to Fiscal Lab. Now, we've got the free ice cream for all Americans on July 4th, and our long name, the Grand Annual National Independence Universal Ice Cream Distribution, Commemoration, and Patriotic Dessert Access Act. Me and ChatGPT had some fun putting this together. So, if this was a true bill, the goal of our website would take you to the congress.gov webpage that would reference the bill. I've not gotten anyone yet to sponsor this bill. So what we have at the moment is, if you click on download bill, here's our draft language for this bill. So we've got some information. The covered individuals refers to any individual lawfully present in the United States on the date of distribution. The eligible vendor is any retail food establishment, grocery store, food service provider that would do it. And this is covered under the Secretary of Agriculture through Food and Nutrition Services. So we've got a fun little description here, some of the data sources that we're referencing and everything else. But for the moment, I'd like everybody to click on Download Analysis. So now we've got this in Excel that we're going to work with. Guess what? This Excel file was not made wonderfully. We're going to have to make some edits to it. So first, I want everyone to click on row 6. We're going to say that the base price for ice cream today is $6.14. So we want to look at how maybe this ice cream rate is growing over time. So we do equals, and we're going to do times 1 plus the inflation rate. This is going to get us that growth rate to see how this price of ice cream is increasing over time, except, whoa, hold on, $20.87 for ice cream. Something's wrong here. The reason is this assumed inflation rate, 2.4, that's not a percent, that's a number. How do we convert a number to a percent? We're going to divide that by 100. So we go back into our equation here, divide by 100. So is everyone with me? We're referencing the 614 times, open parentheses, because we want to make sure we control that growth rate, 1 plus, and look at it from here. Now we've got $6.28, or 29.
That's too much.
Have you seen ice cream prices lately? Maybe not recently. With it frozen outside, I'm not sitting down and having ice cream, but. Okay, so now let's look at something. Remember, if you remember last week, we talked about how you can drag over this corner and drag down. Well, what we're going to do here is now we've made all of these reference cells. So when we look at our bottom one here, we're saying that in 2034, the cost of ice cream is $7.30 and is growing at 2%. And it's at $7.52 by 2035. Great. Okay. Let's go to cell G7 and look at this value. 1.888 billion in order to provide free ice cream for 316 million Americans at a price of $6.29, assuming 95% of the population is taking them up on this provision, gets us 1.88 billion. Now, again, 5% of the population is very wrong, but they're not taking it up. One of the things to notice in this equation, at the very end here, I'm dividing by 1,000. Does anyone know why? Well, we're looking at millions of people, but my dollar value is in billions. So you want to be mindful of how you're calculating this change. Very clearly, that's how we're getting this change here. Guess what? My 0.95 here, is this referencing a cell? No, this is hard-coded in here. So if I was to change my adoption rate and assume that 20% of the population were wrong, my value doesn't change. Why not? Because you want to make sure you're referencing the cell. So what we're going to do here is we're going to delete out this 0.95 and click on the adoption rate. So what was 1.888 billion, when now we assume only 20% of people adopt it, we're now at 1.59 billion. So if I go back and I make this 95%, we're saying that over 10 years, we're at 24 million for a cost over a 10-year basis, assuming a 95% adoption rate.